Good morning, guys, or afternoon, depending on when you're watching this. I just wanted to do a couple questions with you on this practice packet, lesson 7.5, because I want to make sure that we have time to talk about, or actually, I talk about, you guys listen, about how to do the percent increase and percent decrease questions with this formula. So the R represents the percentage rate after it's been converted to a decimal. That's a key piece to this. And to take any decimal, like, I don't know, let's say 2.75%, take any decimal and convert it to, I'm sorry, to take any percent and convert it into a decimal, we will take that percentage, which you cannot use a percent symbol in the calculation. So we have to convert it into a decimal. Percent means per 100. A century is 100 years. 1 cent is 1/100th of a dollar, a penny. So percent means per 100, so you divide by 100, which technically just moves the decimal place 2 spaces to the left. And we're going to have to do that anytime we see a percentage. Now, if this is a percent growth, we'll use 1 plus our decimal. If this is a percent decay, we'll use 1 minus the decimal. If you turn your page, or actually just look at the bottom, oh, never mind, where is it? Oh, I'm thinking of the wrong page, wrong packet. Anyways, in one of the previous packets when you were practicing this, if you were actually doing the practice, I gave you a formula and you had to pick out whether it was a growth or a decay and find the percentage rate. So you could take the 1 plus r and set it equal to the formula. Why don't I just give you a quick example about what I'm talking about? Let's say I gave you a formula for finding the value of some item and it looked like this. And I ask you, what is the percentage rate and is it a growth or a decay? You should be able to tell right away that it is a growth because the number that has the exponent, the number in the parentheses here, is greater than 1, so this would be a growth. To find what the percentage rate is, what we can do is take the parentheses part of our formula, and since we know it came from a growth, because this 1.75 is bigger than 1, then the formula had to come from 1 plus r. We could set that 1 plus r equal to the 1.75, basically subtract the 1 away from both sides to get the decimal version of our rate. So if that's the decimal version of our rate, the opposite of doing the percent dividing by 100 to convert our percent into a decimal, we want to go from the decimal back to the percent, we'll do times 100. So that would be 75%. So if we see that it is a growth, because it's greater than 1, subtract the 1 away, and then the decimal portion gets converted into your percentage rate. All right, so what if it's a decay? So if we had a situation where our value shows a decay because it's less than 1, that means from our formula, we used 1 minus r. So when we subtract the 1 over, we end up with a negative r, and 1 minus 0.8 would be 0.2, negative 0.2, and then divide the negatives away. So that converts to a positive 20% after I multiply times 100. So the decay and the growth can both be found, the percentage rates can both be found by subtracting 1 and then converting your result to a decimal. If you end up with a negative, it just becomes positive because we don't have a negative percentage rates. It's just whether it increases a specific percentage and decreases a specific percentage. Now, here's another thing to think about. If we did a decay and our value is less than 1, what this is actually showing, if this was the 20% decay, that's like a 20% discount or a decrease in price of 20%. If you have a 20% discount, that means you get 20% off the price, then technically you are paying for the remaining 80% of that item. And that's what your formula shows. When this is a decay, you're paying for 80% of the item, or decay is 80% of the original because there is 20% off. All right, and that's what the subtracting 1 would tell you. It would tell you the discount. Okay, so let's do an application problem and make our own equation and make sure we can type stuff into the calculator and all that wonderful things that we ask you to do as teachers. Janice opened a flower store in 1968 called the Hippie's Flower. She made a profit of $9,278 the first year she was in business. Every year thereafter, her profits rose 3.75%. Since the profits are going up, we should automatically know we will be using the version 1 plus R in our formula. But as I talked about, we have to take that percentage rate, 3.75%, convert it into a decimal by dividing by 100, or simply moving our decimal point 2 places to the left. And now we can take that result and use it in our formula. So the formula, the A value here is the initial amount. So that's how much money she starts with. Y will be her total profit. She starts with a profit of $9,278 the first year, and then her profits increase by a rate of 0.375 for each year since 1968 when she started. Now you may also see this formula written where the addition has already taken place. So instead of 1 plus 0.0375, that would give us the decimal 1.0375 when you just add them together. Part 2 of this question asks, what is Janice's profit in 1978? Well, she started the business in 1968. We want to figure out how much she's making in 1978. So that's 10 years worth of business. We are going to take our formula, $9,278 times 1.0375 to the exponent of 10 because it's 10 years later. So we go over to the calculator. $9,278 times 1.0375 is the percentage rate with an exponent of 10. You're going to type that in. You're going to hit enter. And she makes $13,407.01. Now, if I want to see more decimal places, one of the things that I need to do on my calculator is go to my settings. And I want this to float. And then I'll go back. And let's see if that makes a difference. And now I have more decimal places so I can be more accurate with my result. $13,407.12. 13,407.12. All right, so what would Janice's profit be in 1985? So let's figure out how long that's been. 1985 and 1968 is a difference of 17 years. So that gives us a new exponent to try. With their starting salary of 9,278, her starting profits, 1.0375 to the 17th power. So I'm going to go back to my calculator, and I can just use my up button to get my previous calculation, delete or change my exponent of 10 to an exponent of 17, and now it's 17,348.11. All right, so there you go. Now the next thing you're going to do in your packet is just decide whether it should be linear or exponential, and then write the equation using the letters that are given. So for example, Sarah earns $10 for every lawn she mows. Her earnings come from $10 for every lawn she mows. That's linear because she's adding $10 to her earnings every time she mows a lawn. And when the earnings increase by addition, adding 10 every lawn, that would be linear. Part B, Wanda charges $2 for the first hour of babysitting, and the price triples every hour. So that means we are multiplying times 3 to get a new cost for every hour that she works. That is exponential. So her profit comes from starting at $2 and her price tripling every hour she babysits. Next one, George has $200 in a bank account that earns 1.7% interest each month. And this is exactly what we were doing on our opening example. So what we're going to do, because it's a percent increase, we're going to need to use the formula y equals a times 1 plus r to the x. Remember that we have to convert our percentage rate to a decimal by dividing by 100 or moving the decimal 2 places over to the left. And now we can put our values into our formula. So the amount in the account starts at $200 and then increases 0.0175 every month. Now, if you wanted to write it as 200 times 1.0175, instead of putting the plus sign, go ahead and add them together, then you can do that. All right, I think the rest you should probably be okay with. You're doing an application problem about population growth of fruit flies for a friend of mine who works at Kansas University. He's a Jayhawk. Um, and then you're going to just decide whether the table is a growth or a decay, and then give me an explanation why. Remember that explanation needs words, doesn't have to be an essay. And then determine if the tables represents linear or exponential or maybe neither, and explain how you can tell. Again, written explanations. All right, guys, have a good day and stay safe, and we'll see you soon.